Alright guys, we're going to make some histograms now using the ACT data that we got in class earlier today. Histogram, as I said in class, is really just basically a bar graph like you've been making for a lot of years, except it's for our statistical functions with our quantitative data. We'll still see some bar graphs with some categorical or qualitative data later on, but a histogram is really focused on the number of times that a piece of quantitative data comes up. So let me set up my histogram first. Just gonna get an X and a Y axis. We don't need the negatives, so just the positive sides. Move that. Okay, on the x-axis or the horizontal axis, we're going to have our data. So these are ACT scores. Over on the left, we're going to have, there's 4 different kinds of histograms. You can have a frequency histogram, a relative frequency histogram. Frequency histogram will count up how many of a point shows up. So we're going to do a frequency histogram for this data. Over here on the left, it's just going to be counting how many 23s were there, how many 20s were there. A relative frequency histogram is going to be percentages. So I would need to know how many data points I have here total. I've got 48. And so in my 23 bin, I would put, I think there were 11. So I would get a percentage, 11 out of 48, and I would put a probability or a percentage over here instead of a number. Then you can have cumulative histograms. That's going to be counting up how many out of the total there are. So we would still scale this the same way we would a normal graph, but it's counting out of the total. So this, by the time that you came over here all the way to the right, because there's 48 data points, you would have a top bar being 48. And you can have a relative cumulative. That would again be the relative part being based on percentages. So you would go from 0% of the data to 100% of the data over here on the right. So let's build our frequency histogram. We're just going to do our counts. If you really wanted to, you could start at your origin and just label this as 0. That's not necessary, and when you do it in your graphing calculator, it's not going to do that either. So let's just show a break, and let's start at 11. Well, 10. I'll go with 10. 11. Just going to number these. These intervals or bins or ranges, as they might be called in different areas. Intervals, ranges, or bins down here. It just shows what data point you're going to put in. Because this is just from 12 to 13 on this one, and my scores are discrete, meaning they don't have decimal values, the only thing that would go into this range here would be a 12. If I had counted by 2s and my bins were of size 2, so this would be 12 and maybe 14 here. 12 and 13 scores would both go in that bin. So depending on the size of your bin, looks at how many different scores you might be looking to put in there. For ease of this first one, I figured we could just make a bin of 1. Bin size is not always going to have a right answer or a wrong answer. You have to look at what gives you a good picture of data, a good shape. You don't want a flat one, you don't want lots of undulations either. Alright, let's look at the data. I have sorted this already in my calculator. I got a 10, there's one 10. I have no 11s. I have no, put that in the wrong spot. 10 must go here. I have no 11s, I have no 12s, I have no 13s, I have one 14. I have no 15s, I have a 16. I have a 17. Got 1, 2, 3, 4 18s. 1, 2, 3, 4. I have 1 19. 1, 2, 3, 4, 5, 6, 7 20s. 3, 4, 5, 6, 7. 1, 2, 3, 4 21s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 23s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 25s, I have 1, 2, 3, 4. No 24s, I'll leave it blank. 26s, there's 2. Oh, I messed up. 22, there was 1. Darn. Alright. 1 there. Here was my 23. 23. 21, there was 4 of them. I did that one right. Here was the 20. Here was the 19. Another great reason to use pencil. Okay. 24, there were none, so that should have been blank. 25, I had 4. 26, I have 1, 2. I skipped a number. 27, 28, 29, 30, 31, 32. Okay, I'm on 27. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 28, I have 1. 29, I have 3. It's 29. 1, 2, 3. I have no 30. I have no 31. I do have a 32. Okay. So here's my histogram. The filled in bars are the ones I wanted. This actually turned out pretty well. We'll look more about what the shape of a normal distribution is going to look like. It'll be a lot like this. Some things that happened because we had the small bin sizes is maybe we could have eliminated the gap there, or this dip right here. We might have been able to eliminate that gap there. Something else that happened in this data set was that the mean and the mode and the median were all 23. That's going to happen, or they're going to be really similar in a symmetrically shaped histogram. So somebody in class asked, is that going to happen? If it's a symmetric distribution, that usually will. So what that showed that happened for us was that we had a pretty good data set, because ACT data usually is assumed to be symmetrically distributed like this on a bell curve, or what we'll call a normal curve in class. So this worked out. Again, things to notice on the histogram. This was a frequency histogram because we were just counting the numbers over here on the side. I was just counting how many times I had that data point. I scaled my x-axis by ones. These are called the bins or the intervals or the ranges. All three of those are used interchangeably. I can scale this any way I want to. In this case, I made it ones just for simplicity, but I could have done maybe 2s and leveled this out a little bit, maybe, or 2s or 3s. Again, that's a lot easier to try out if you're using your graphing calculator versus trying to make this by hand. But there's basically what a histogram looks like.